co-chair of the Analytics and Big Data Committee. I'm also the chairman of the board of the Active Archive Alliance. And my job that actually pays my paycheck is at Spectra as the head of worldwide marketing and product management. I've found I spend most of my time these days really looking at technology trends, the intersection of technologies from HPC to media entertainment, the video world, and a lot of what enterprise is doing. And it's a really interesting job to see how technology trends are starting to intersect, and we're not seeing quite so much different technology in the different markets. And as I was putting this presentation together, I'm doing a keynote at a cloud technology conference next month and starting to put together the slides for that. So what I found was really interesting is that a cloud presentation could be used at a big data conference as well, with some tweaks. So with that, I'm going to jump into the presentation and start talking a little bit about what is disruptive technology. As we're looking at big data, I think that the industry, with terms aside, and I'll talk about some definitions in a little bit, has really been changing around the change from a disruptive technology to disruptive users. In general, the enterprise has really held on to the assets of the data, the assets of the storage, and the information that they produce. But the enterprises that are increasingly more successful are the ones who are figuring out how to kind of give up that control and unlock that data to let their users figure out what is the next big thing for their organization. There's a book by Clayton Christensen. If none of you have read it, or if you haven't read it, it's actually worth reading. This one was written back in the 1990s. It's called Disruptive Technologies Catching the Wave. I believe Clayton was the first one to start to dub the term of disruptive technologies, at least in a real well-known way. However, he wrote another book recently called The Innovator's Dilemma, and that's where a lot of the really neat stories about what kind of findings have been made by utilizing big data technology, the kind of advances that we're seeing outside of just the research industry, the medical industry, but out in the real world, for customers who, or users who maybe only have 10 terabytes of data or a terabyte of data, but are figuring out how to leverage these innovative kind of questions and answers out of a big data analytic environment to come up with some really cool stuff. So new technology is disruptive, certainly, but it's how the users are starting to use that technology that's becoming a bigger story. At a press conference, at a trade show, typically over the last decade, we would have been talking about the newest flash memory that's come out, the 4 terabyte hard disk drive, the LTO6 tape drive, a new generation of processing power. And all of that's almost become accepted as something we will have. Every year or two, we will see hardware technology continue to innovate. We'll have faster networks, et cetera. But what's really starting to become interesting, and you see this in the presentation we just listened to, is what are people doing with all that data that we're keeping, and how is that evolving? That's becoming a really interesting story. So I thought looking back into history at the old Model T car and the kind of disruption that caused was an interesting way to look at this into the past. That cars were custom made one by one, and the Model T car was the first one to come off the manufacturing assembly line. The innovation that, as you look back and being able to go to mass production of a vehicle, was absolutely disruptive. The horse and buggy, for all practical purposes, was obsoleted. It changed the way we lived, the way communities grew, the way people worked. It changed the way people lived. And it wasn't the car that was the big deal. It was the fact that they were able to implement a new way to manufacture the car and bring it to the masses. Again, looking at bringing that technology to many people was the disruption a lot more than the vehicle itself. So as we look back into the last decade, I think some of these slides are really interesting to look at. The idea of what happens when you put a cell phone in the hands of everyone in the world, and even more importantly, what happens when those cell phones have cameras, have recording devices, and are attached to the social media network. It's really changed the way the world is being governed. A lot of the countries who might have historically liked to control the video and the input of what's happening in the world no longer can control that. The people have a voice, whether it's across Twitter, if it's across social media, if it's Facebook, that the people's voice has really been brought into the look into what the way data is being used. And I don't think any of us, when we saw the cell phone come out, would have thought that this could have evolved. It's hard to fathom that the people who manufactured the first iPhone, the folks who manufactured the first cell phone, would have expected that this would cause such a change in the way the world is watched. What it's done is it's really changed from how we're using data to why we're storing data. It's not just a matter of how do we store data, how do we store it effectively, redundantly, cost-effectively, reliably, but it's how are we accessing that value. And that's where I think, even as we sit at these conferences, a lot of us scratch our heads in looking at how do I implement a Hadoop infrastructure. I know for my own organization, we had a test bed for Hadoop that it took our IT staff several days to install because they just couldn't get their mind around the new concept. But it's worth it. It's worth it to go figure it out because we can see how having a big data infrastructure can unlock a lot of the value of this data that we're storing. A couple of stories about big data, and I love these stories. I could read these all day long. On the way organizations are implementing these big data infrastructures and what kind of value justifies as an organization going ahead and figuring out how to build a Hadoop infrastructure or build your own analytics infrastructure, as Addison mentioned, is now more than half of the market. Whichever approach you take, why it's worth staffing it and putting a budget on it. I recently was talking to some folks over at Hortonworks, and it was a lot of the same data that I'm hearing this morning, that only about 100 companies have a production Hadoop infrastructure. However, they believe that every one of the Fortune 500 has it somewhere in proof of concept. So companies are figuring it out, and they're having to figure out, how do I allocate staff? How do I allocate budget? And what's the justification? So a few of the really interesting things that this Clayton Christensen book talks about in part is looking at DNA sequencing. There's a company called 23andMe that will analyze people's data for a couple $100. An individual can go in, and they're only looking at a bit of your DNA strand. They're looking for major markers, breast cancer, pancreatic cancer, issues related to heart disease, but it's predictive. You're going to the doctor, you're spending $200 or $300 out of your own pocket to predictively identify if maybe you're at risk of some kind of genetic problem. Steve Jobs paid well over that into the six-figure sums to take a look at his entire DNA sequence as well as the sequence for his tumor. The doctors used that information to select which medications they were going to treat him with, and then they were able to proactively identify when those would become less effective and put him onto new medications and predict which medications they should have him on. Granted, Steve Jobs wasn't able to survive his cancer. However, they do believe that because he went through this process, he lived several extra years. And think about what we learned from that as an industry, from the medical field, on what that can apply to for other people. Looking over at a slightly less morose topic, but still interesting on the medical front, is how the predictions for flu vaccinations are being done these days. Historically, influenza trends were marked by the CDC, and they would be able to identify where a trend was going to hit, that we were going to need to have a new vaccination into the American population. Typically, it took about 2 weeks for them to make that decision, that by the time you and I all get sick, we hunker down for 2 or 3 days, hope we'll get better before we go to the doctor. Once we go to the doctor, it takes a couple days for the doctors to log the results of their information. It takes a few more days for that to get logged into CDC, and ultimately it's about a 2-week process before the location of influenza breakout is identified. Google decided to take a look at this and see how could Google figure it out. Google decided to correlate it's about 45 million different mathematical models on who's searching for treatment for stubby nose, who's searching for treatment on availability of NyQuil at my local grocery store. As travelers are starting to hit different areas and they're starting to come down with a fever, what are they Googling for? 45 million different models. And what they found is that Google is able to predict within about a day the breakout of an influenza pandemic. And so you look at the difference between a day and 2 weeks. And Google's data, they aren't even out there trying to figure out what's the solution, what is the antivirus cure, or anything like that. They're just looking at human behavior and able to predict that. And then the last one I'll share with you is a gentleman named Oren Etzioni. He's a Harvard grad who started to look at airplane buying behavior, airplane ticket buying behavior. He sat on an airplane and talked to a bunch of folks on the plane and asked them, what did you pay for your ticket? He found there was, as we would all guess, a wide variety of how much each person paid for that exact same flight. Even airlines often can't predict what their ticketing model is going to look like. However, he created a product called Metacrawler. Metacrawler would take about a 41-day period of metadata information about airplane ticket trends, and over a couple of years, they were able to predict with a 75% accuracy what the best price was for a ticket. taking into an enormous amount of different activities, enormous amount of metadata and information. That gentleman got his company bought by Microsoft for $110 million. It's now part of Bing. But you can see that that kind of technology is driving all kinds of creative and interesting stories around the world. So as a CIO, and as you sit here as a technologist, whether you're on the business side or the technology side, there is true value in implementing a big data infrastructure. It's not easy, but there's so many proof points out there on why you should do it that you could just go on and on talking about that alone. So as we look into what is big data and how do we define big data, I think that's one of the things that we really as an industry need to not be too stuck on. That the idea of what big data is a lot more than a very large data set. There is a lot of information out there about how quickly data is growing. IDC predicts that we'll have 40 zettabytes by 2020, which equates to about 5 terabytes per person, that being 5 terabytes per man, woman, and child by 2020. There is an enormous amount of data out there. But the interesting part is 68% of it last year was created by individuals. It was not created by enterprises. Yet the enterprises are the ones who own the keys to most of that data. It's stored on some kind of enterprise infrastructure. And this is where it starts to go to, how do we enable the users who are creating the data and the users who are thinking about interesting questions to ask of the data so that they can move their industry forward. That may be from a marketing perspective, looking at where should I market, where should I advertise, what will get my customers' interest. From a research perspective, it may be figuring out how can I target the very next influenza virus to the right location. From a CIO's perspective, it may be something to look at where should you invest in your business. There's lots of different questions, but it's the individuals who are coming up with asking the questions that we really need to be enabling. That historically, large companies have been very strict on staying focused on the areas that they can prove that they can be successful. If you look at a very large Fortune 100 organization, very few of them are really looking at what is the thing that we could be doing 2 or 3 years from now. Let's take some risks and let's invest there. Instead, they have statisticians, they have data analysts, all looking at the past and looking at what's made us successful to date and continuing to put their money there. It's a huge shift, I believe, in not just the American economy, but in the worldwide economy, where the companies who are going to take risks and the companies who are going to start to look at predictive analysis, they're really going to be successful in the future. So it's really it's a new approach to how we're utilizing our data, to not look at how do we protect the past, but how do we predict the future. And I really like this definition. I'm going to read it out loud, even though most of you can probably read it yourself. So what is big data? It's a new generation of technologies and architectures designed to economically extract value from large volumes of data, from large volumes of a wide variety of data by enabling high-velocity capture, discovery, and analysis. So that capture, those are people who are capturing it. It may be computers who are capturing it, but it's also putting it in the hands of people to analyze and utilize it. There was another webinar going on today with one of my customers from Spectra that is in the supercomputing space, and they said something on one of their slides I thought was interesting to share. So the Blue Water supercomputer is funded by the NSF and is at the University of Illinois. For the first 19 years, NCSA, who owns the supercomputer, it took them 19 years to store their first petabyte of data. A year ago, they stored their second petabyte of data as their computers started to figure out what data they wanted to keep and started to analyze. The Blue Water supercomputer is designated 100% to scientific research to be able to store and ask these types of questions that we're talking about today. In the first 6 weeks that this supercomputer was up and running, they stored a petabyte of data in 6 weeks. It took them 19 years previously to create that much data, and now they're on track at about a petabyte a week. So you can see the compute side creating new data at about the same increased velocity that the users are starting to create the data. But just storing it, the reason they were able to fund storing all of this data is because the kinds of answers that they're going to be able to answer for meteorological, for science research. So what is big data really? Whether it's a terabyte of data, if it's 100 terabytes of data, if you have many, many petabytes of data, and this goes back to kind of what Addison was saying, is some people are so proud of, I have the biggest data set, and That's not really what's so interesting, is what are you able to do and what kind of information are you able to derive from that. Historically, all of these storage shows we've been to, whether it's the Storage Developers Conference, SMW, any of the ones that all of us have made a career of being a part of, we mostly were looking at how can we more intelligently back up the data that we have? How can we create faster ways to access the data? How can we snapshot and protect it real time so as it's being created, we don't lose anything? But really, we haven't done a lot to look at how can we derive value from the data. And that's really what big data is about, is store everything because you don't know what questions you're going to ask of it, and you really don't know what questions you're going to want to ask in the next 5 to 10 years. But not just that, store in a way you can access it. A lot of these applications out there are proprietary data formats. They're offline data formats sitting in backup files. Snapshots really aren't all that usable to a file system or to an analytics engine. So as you start to look at it, is it going to be a huge shift for our industry? Certainly you have to protect your data for compliance reasons. Certainly you have to protect the CEO's PowerPoints in case he deletes them mid-use. However, there's a much more strategic initiative here of how do you keep these analytics engines able to access the data, whether it's the HDFS or Luster file systems, or build your own kind of proprietary analytics engine that you're utilizing in your data center. So the no delete policies do make sense. Storage is getting inexpensive enough that just keeping your data because you don't know how you're going to use it in the future does make sense, but you have to keep it accessible, and that's going to be a shift in the data center. It's going to be a shift from traditional data management methods to new methods where file systems, analytics engines can access all of that data. So correlation is king. And starting to look at how do we find this information? How do we ask the questions? I look back at, I have a degree in biochemistry, which of course has nothing to do with storage, but this is where I've ended out. And when I was in school, we did a lot around creating a hypothesis and then figuring out how to prove your hypothesis is right or wrong. A lot of problems really as you think about that. First, the hypothesis ideally was coming out of my own head. And then I was going and figuring out what test can I run, which was limited by how many hours I had in the day, how good I was at running the test, any variety of things, very individualistic. Now certainly research can scale well beyond the individual, but when it comes back to it, big data instead is not about figuring out what hypothesis to ask, is running the analytics and figuring out what are the answers to the question you don't know how to ask. A good example is Walmart, and a couple of people this morning I heard talk about this same case study. It must be pretty well known. But Walmart is one of the biggest developers in the retail space who started to adopt big data infrastructure. Very powerful organization. Obviously, it's all about making money for them. And what they were able to determine is, as they looked at the buying trends within Walmart, that when a hurricane was coming, they would look at what buying trends were there for different products in their stores. And they found that the Pop-Tarts were the most common product and that the buying of Pop-Tarts went up exponentially when there was a hurricane predicted. They don't know why. They don't know what drives people who hear about hurricanes to buy Pop-Tarts. All they know is that it is the fact. So what they would do is put their highest margin products next to the Pop-Tarts at the front of the store. So as people were coming in, make your Pop-Tarts a screaming good deal, but then next to maybe your lanterns that are going to be very high margin, and people are likely to grab both. And you know they're going to be there looking for Pop-Tarts. So the difference between how I would have done that model when I was in college and been looking at what products will customers want to buy when I have a hurricane, instead they just looked at where are sales skyrocketing and what products can I make more money if I put them next to it. It's a different way of approaching it. So historically we've cared about why, and that's really, I think, the biggest shift in this industry is it really doesn't matter why we see trends, it's just what are those trends, and as businesses, how do we capitalize on them? So what this is really doing, this usage model is driving this digital revolution, and our technologies must follow it. So as we start to look at, that's interesting, I think these stories are great, we all like to hear about them, but what are manufacturers, what are the vendors, what are the users using the technology going to need to do to be able to change? So I've mentioned that this is going to require a huge shift in the data center, one that we're starting to see in some organizations, but we're going to have to start to see this kind of shift in the data center in a lot of different ways. So as you look at the world today, we all are talking about the growth of the exponential growth of data. The data sizes are inconceivable. whether it's hundreds of terabytes, it's petabytes, it's exabytes that you're dealing with. All of those kinds of data set quantities are becoming commonplace, not just in research, not just in high performance computing, but in medical facilities, in retail, media and entertainment, exploration, life sciences, finance, all those different areas are starting to grapple with how to handle this. And that's changing the data storage world for all of us as manufacturers. So we look at what is this going to lead to, and the concept of deep storage is one I don't know if you've all heard about yet or not, but it's a term that's starting to be coined through the industry of looking at storage that you can leverage in open systems, through analytic engines, whether you're building your own, whether you're using HDFS, whether you're using Luster, GPFS, whatever your technology is, that it has the ability to access your deep storage. Most of that deep storage is accessed over some kind of REST protocol. REST being the web protocols, S3 being the most well-known from Amazon Web Services, as the way these applications are communicating with their storage. There's a lot of reasons that REST is starting to be the standardized protocol, and it's for these deep storage infrastructures that are being presented to the analytics engines. Don't be thinking so much about your email servers or about your databases or the areas that you're attacking for compliance. Those problems are well solved with the technology you have today, and those are problems that you need to continue to solve with the technology today. This is really looking at how do you want to store your data to set yourself up for success when you do have a big data initiative dubbed as important within your organization. So looking at storing your data over REST interfaces, utilizing web protocols, but having it on the kind of infrastructure that regardless if it's accessed frequently or infrequently, you can afford to keep that data for the long term so that when you go to figure out what questions to ask or what answers you need to prove, you have the data available. The attributes of deep storage in large part is where you're starting to see the intersection of cloud storage and big data, and this is why I was able to use this presentation in some ways between two different conferences. That cloud storage has been about how do I make it easier for my users to store data, how do I do it more cost effectively, and in general, it happens to be that you're using protocols that are REST-based web access protocols. As Addison said, because of security issues, the size of the networks compared to the size of the data, a lot of these cloud infrastructures, when it's public cloud, aren't really what you're seeing customers adopt for big data infrastructures, but it's the same technology. So when you hear about hybrid clouds, private clouds, public clouds, to me what that really is talking about is you're using some kind of REST-based object-oriented storage for the deep storage of your assets. And that can be on-site, off-site, it really doesn't matter. The value of it is it's cost-effective, it's easy for applications to integrate with. Maybe the applications you're using to integrate with that storage today are different than the ones you're going to be using in the future. But the attributes of the data is it's very, very accessible across multiple people or multiple applications. Typically, they're object stores, and I'm going to talk about that just a little bit here in a few minutes. And those object stores are then accessible to some kind of file system. And typically, they have their own data protection built into them. You very rarely will see a cloud infrastructure, an enormous object store, a Hadoop environment being backed up. Typically, you just see that they're using cost-effective storage with 2, 3, 4, 5 copies of the data, either in a single cluster, geographically distributed. There's different ways to do that. But typically, what you think of as data protection is built into the clustered system itself instead of done by a separate application. So looking at cloud storage and the protocols that we're talking about, really it is the next step in virtualization, and it's virtualizing your storage so that you have very simple access across any type of user, any types of security protocols to the data. You can use a gateway to get access to it, or you can write your own custom scripts and custom environments to be able to access the storage. Whether you're the kind of customer who will go out and create your own scripts to get data in and out through puts to this kind of object store and write your own for your own workflow, or if you really are standardized on a NFS or CIFS kind of gateway, there's solutions out there on how to get access to this data, but it's how the data is being stored is really critical. I'll talk about that a little bit more. So the intent of file systems historically was to get back past the difficulties of block storage, that you had to have an IT staff that could provision block storage. It was complicated to allocate, complicated to reallocate, and certainly difficult to make accessible to lots of different applications. entered the file system and the large adoption of file systems a decade or so ago, and you saw that it was much, much easier for applications and users to interact with their storage. It was easier to provision the storage. It was easier for different customers to be able to utilize it in different ways. But there are some issues with file systems that we're starting to encounter in the big data world. And in a lot of cases, that's just the structure of the way a file system is built. File systems, and if you think about it, most people will say, at least most technologists will say, a file is an object, so how is a file store different from an object store? And there are different ways, and I'm going to talk about that a bit as well. But the metadata around the file has continued to evolve. What most of us think about of the metadata within a file is things, there's file attributes. It's things like creation date, size of the file, maybe what type of file format is it, those types of things. And that's certainly useful. All of us use search on our laptops daily, I would think, to look for that email associated with a certain topic, those types of things. But the amount of metadata you can automatically associate with a file is somewhat limited as well. File systems are nested, which essentially means you have the capability to have a directory within a directory within a directory tier. All of us know this, but that's why you're starting to see issues on creating metadata that is accessible to lots of different applications around a file system kind of protocol. It's also why you're starting to see file systems getting tapped out. If you look at the number of files a file system can support, it scales typically into the billions or trillions. It's an enormous number of files. But these big data infrastructures consistently need a lot more files than most file systems are comfortable handling. Then you start to see clustered file systems and parallel file systems. So we are pushing the capabilities of file systems from the number of files that they can handle, but we're also pushing file systems from the amount of content they can store. So if you look at the typical NAS solution, and depends on whose vendor you're looking at, when you start to get to about 5-10 petabytes of storage, typically those systems start to kind of break. You stop seeing the same kind of performance that you've seen in the past. You quit being able to continue to get the same kind of reliability aspects that you've expected. So from the growth of data perspective, and from the ability to assign metadata and deep levels of metadata, we're starting to see object stores in the big data environment becoming more common. So object stores are flat versus hierarchical. It's the concept that you still have files, but then you make collections of files that you move into your storage, and you can create buckets of data in that storage. So maybe you take 100,000 files, put them in a single bucket, and all you're managing is one flat bucket. But what's great about that is you have a lot more metadata about the information in that bucket. You can have information about the patient, the type of cancer the patient may be, an MRI is associated to. You can have history about how many times you've seen that patient, and create and store all of that data collectively together. So it helps go on past just some of the physical limits of the file system. But most importantly, all of that data from the file system is stored in a single bucket, and that object has the metadata that's accessible for applications to get access to. These applications then, whether you're using a traditional application today that has a file system front end, or you're looking at implementing analytics in the future, all of this data you're storing is self-describing, and the metadata can be utilized by those new applications in the future. So one of the biggest things that we're seeing, whether it's through the Analytics and Big Data Committee in SNIA, or if it's through the other initiatives that I'm involved in, is an increasing trend towards go ahead and not just keep your data today, but keep it in a well-described way that has plenty of metadata around it, and that is accessible to lots of different application types, because your organization may not have a big data initiative today, or may not have landed on what technology they're going to use. But if you start storing your data this way, you'll be set up a year or two from now when your initiatives do get going within your organization. So looking at the kind of enriched metadata, just to give you a feel for the difference between a file and an object store, both of them contain data and both contain information about the data. But looking at the kind of information you can have when you have all your data grouped into an object is really where a lot of the meat of this information is. That as you start to look at what are the trends around the data, what are the trends and information you want, you probably need to know a lot more than just the file type and who created that file. To really get the value you want out of Steve Jobs' cancer is knowing a lot more about the content within those files versus just knowing about the file types. So I think it's pretty obvious that why the metadata is important and associating it as you're storing the data is important is becoming increasingly strategic within organizations, even if you don't know today exactly how you're going to leverage it. A few other cool things you get is you get simple data access. That the idea of RESTful interfaces across your storage systems. You can have multiple different storage systems that are all using the same kind of access protocol. So that means that in your active archive years from now, regardless of what kind of storage you're using, you'll still be able to access it. You'll be using these new REST-based interfaces where most of the developers prefer to write programs today in some kind of web access REST interface type format. So the developers coming out of college that are going to be those disruptive thinkers in your organization will be able to access the data without having to go rely on the IT staff to get it back for them and find storage to put it on. So really enabling those folks who are coming into the organizations or who are tasked with the big data initiatives in your organizations, keep the content available to them. It's very easy to expand and contract, whether you decide you need to store more data and you delete more later, how you handle data protection, all those things that you hear about that are great in the cloud, you can have access, you can use those applications for your big data initiative as well. And it's the same stuff. It just happens to be, we talk about it as two different markets, but ultimately, those attributes of your data are how you're going to enable your big data initiatives down the road. And then, like I mentioned, the data protection is built in. Don't try to shoehorn these kinds of initiatives into your traditional data protection methods. They won't scale. You will not be able to meet your backup windows. This is typically unchanging data. There's no reason to back it up more than once. Just have a couple copies of it. So think about what's the practical way to handle your data in these kind of environments. And you can really accomplish a lot within your organization. So that as you're looking at how do you enable the disruptive thinkers, how do you take advantage of all this content that's coming into your organization, put it in formats that you can share it, where you don't have to have your enterprise IT staff in the middle to give people access to that data. Even if you're not ready as an organization to unlock all your data to those users, at least have it stored in formats so if you do decide to at some point in the future, it's very easy to give access. Then it's just a matter of security permissions versus having to rewrite the data. So I really think that with this growing unstructured data that everyone's starting to deal with, exponential data growth of unstructured data, which all of us have, is thinking about how do you store that data today to make it easy to access it sometime in the future, whether that's in a day, a year, is really what the job is of storage administrators right now. And with that, I think that is it on my slides. If you have any questions, I'd be happy to answer them. I'm on panel later, so yes.
Okay, so object storage.
Yeah.
Coming from an object software development background, I think of objects as not only containing my disparate data, but also operations, operands, that give me get and put access to that data.
Absolutely.
Do your objects going into object storage have embedded functionality? You mentioned data protection. Is that wrapped around the data?
Typically, it's on the client. So in those get and put client-server kind of infrastructures, typically the client's deciding how many copies they want and where they want those copies. There absolutely are gateway appliances that will do that for you, where you set a policy, put 2 copies, one up on my web service cloud, one on my local infrastructure, one on my tape, whatever it is. But for the folks who are developing their own clients in that get put web service environment, typically the client's designating how many copies and where.
But it would seem more reasonable to put at least some level of security policy functionality into the object, each object, so that if some client tried to access who shouldn't have access, why would I want, a bad client to have access to my data?
Yeah, and I think that the clients that I've seen written, some of them have a great deal of security built into them, and there's access to only a certain copy of the objects. Others there aren't. Others it's not written into them at all. And that's kind of the cool thing, I think, about this model is you can take advantage of the security permissions that are built into, for example, S3, or you can add your own. So in a lot of cases, like if you look at what Penzura has implemented, Penzura is a gateway from NFS to S3. In that case, they can have a single copy of the data protected by only certain users. Other users have the ability to do things like deletes, expires, those types of things.
Yeah, the data protects that. It fixes itself. Because my understanding of S3 is I can write a bad client.
You absolutely can. And that's where you either have to rely on putting security in your client or buy an off-the-shelf client who handles the security.
That's why I don't view it as a true object model. Forgive me. That's what I meant.
I understand what you're saying. I mean, there's a lot of flexibilities, and the implementation for your organization is absolutely critical. Just having guys who can write clients that don't have appropriate security built into them is, you know, giving the keys to the Indians, so to speak. Any other questions? Yeah.
What are some of the disruptive technologies you see coming along that allow the near real-time analytics and actionable type of analyses?
So the question is, what kind of areas do I see real-time analytics really affecting? And a lot of it, I think you're seeing it a lot in the web as far as being able to sell data on the web that customers are interested in, whether it's things like how do you advertise Netflix and what movies you want to get people to download. I think that the biggest opportunity right now is somewhere in the retail space, that being able to predict user buying trends and get the right information or the right product in front of them is the biggest area that's starting to evolve. Within the research community, we're seeing a lot of the analytics in the oil and gas industry right now, that they're being able to predict where to send ships to get seismic data to make good decisions. The other area that I think, for a lot of different reasons, is in security. So the video surveillance and security market, whether that's the commercial video surveillance of retail stores, whether it's the information that folks are capturing off the Boston Bombers for the marathon off of their cell phones and being able to get information off that, or if it's in the security space, these kinds of creating objects that have information about the rich media as well is probably the biggest area I think money's being invested. We're seeing that in a lot of cities who are grappling with real big security problems on implementing around the corner surveillance like they have in London. So I think there's a couple of growing areas. I think the Fortune 100, who all have POCs of Hadoop, are going to figure out the best way to take advantage of those, and you'll see that coming in the next couple of years. I'm not sure where that will be, but certainly in rich media areas where they have video, audio content, that they can use that to help predict. Security is a big area, and the retail on the web is a big area as well. Any other questions? Yeah.
Talk about the use cases.
The adoption rate of what? Yeah, I think the adoption rate, and probably leaning more on folks like Addison, who have the data around exactly what kind of adoption, can give you hard numbers. But the adoption rate we're starting to see is across the different members of ADDC and the work groups that we work within, has been Hadoop is slow, but there's POCs everywhere. People are playing with Hadoop to figure out how to implement it. But the fact that Addison is saying that they're seeing build your own analytics engines are more than half the population, I think is probably indicative of the biggest growth, that folks may not be implementing Hadoop, but they have some kind of analytics engines in their organization that they're trying to utilize before they jump into a full big MapReduce infrastructure. So like they said earlier, the Hadoop has been around for 8 or 9 years. I think big data really is a market, and the amount of money that's going to be spent on it is still 2 or 3 years away. The technologies are stabilizing. Things like most of the infrastructures for big data don't have the concept of storage tiering built into them. There's issues around security. There's a handful of things that are still being sorted out. But there's so much value to the ones who are implementing it. I don't have any question it's going to take off, but I think we're still probably 2 or 3 years from the average organization having a budgeted and implemented big data environment. That's also my personal opinion. All right, I think I need to hand this off. I don't think we're taking a break this time, so everyone's going to have to hunker through till lunch. Next up, we